space and missile assets are becoming increasingly more important to improve the effectiveness of our warfighters around the world and to ensure the security of our nation and its allies, both in the theater arena and in the strategic arena. We need to more fully explore space and the near-space environment in order to answer such questions as, what are the effects on satellite performance of radiation, of magnetic fields, of solar flares? We need to know how our early warning satellites can better identify and track enemy missiles against various space and Earth backgrounds. Due to the critical nature and high cost of space and missile systems, the demand for absolute perfection in developmental testing and evaluation of system design is of the highest priority. We need the best available expertise and facilities to support research and development. We need to provide a wide range of products and services as part of the integrated acquisition process for the space systems of the future. There is one organization that provides a single face to the customer for all DoD space testing needs. It provides the world's best and most complete capability to help plan, conduct, and report test and evaluation of advanced research and development. That's the mission of the Space and Missile Test and Evaluation Directorate, America's Space Test Center. The Space and Missile Test and Evaluation Directorate is part of the Space and Missile Systems Center, SMC, the Air Force Acquisition Organization for Space Systems. The Directorate's headquarters is at Kirtland Air Force Base, New Mexico. There we are developing a close working relationship with one of our primary customers, the Phillips Laboratory of the Space and Missile Systems Center, which is also headquartered at Kirtland. Together, we jointly support our most important customer, Air Force Space Command. In addition, we work closely with the Air Force Operational Test and Evaluation Center at Kirtland to establish the Combined Test Force for Space. This will help the Air Force better utilize the test assets available and to ease the transition from developmental test to operational test. We also have other operating units across the nation. We provide state-of-the-art launch ground support in the area of vehicle processing, including flight hardware installation and system validation in our own facilities. For example, our new experimental payload facility at Vandenberg Air Force Base, California, can be used to process a variety of payloads, ranging from this small Rex-2 satellite designed to improve satellite communications and navigation control, to much larger and complex spacecraft requiring cleanroom capabilities. With our own resources, combined with NASA, Air Force Space Command, and a vast network of military and civil resources around the world, we operate a global test range that encompasses the atmosphere and orbital space. As part of the integrated product development teams for SMC system program offices, we provide comprehensive test and evaluation support throughout the development and acquisition process for existing as well as new space programs. Bringing us in at the initial stages of planning helps control cost, enhance performance, and minimize the need to develop mission-unique equipment. We also provide a unique capability for new satellite programs. Personnel in our activation office coordinate the facilities, manning, and training associated with bringing a command and control system online. The successful support of the first Milstar satellite is a typical example of those efforts. Staffed with the best managerial and technical experts in the business, we have over 3 decades of experience in all facets of R&D. In addition to developing and testing our own launch boosters, our launch testing support has been invaluable to the developmental programs of many other DoD space and missile agencies. As the responsible test organization for the F-15 anti-satellite program, we conducted the only successful satellite intercept in the history of DoD. For over 30 years, we have managed and conducted ballistic missile verification tests for the Reentry Systems launch program. We also support development of reusable single-stage launch vehicle technologies for NASA, including all the flight tests of the DCX, a vertical takeoff, vertical landing vehicle, and the DCXA, which has advanced technology components and systems. For experimental payloads, the Directorate offers a complete menu of services for testing and evaluation. We have an impressive history of supporting a multitude of government and civil agencies and laboratories. For each customer, we help to create a combined test force team. The team includes all the organizations and personnel necessary for successful cradle-to-grave testing. We assist the customer through every step of the R&D effort. We design in success with systematic test requirements and traceability throughout the test process. Our automated scheduling tools help to plan and coordinate all the required test range and engineering resources. Using our unique expertise and experience, we conduct safety and contingency planning to achieve a successful mission. Today, we provide our customers with one-stop shopping to suit all kinds of R&D launch test requirements. We offer a wide variety of platforms and launch vehicles, which can be tailored to each customer's needs. We manage the Space Test Program, or STP, a tri-service program that has provided successful spaceflight for about 400 advanced DoD-sponsored R&D experiments not authorized to fund their own flights. The program is under the executive management of the Director of Space Programs, Office of the Assistant Secretary of the Air Force. STP experiments are ranked by the DoD Space Experiments Review Board, SERB. STP's primary flight mode is our Tri-Services Experiments Platform, or TSX. TSX, like its predecessor, the Space Test Experiments Platform, or STEP, is a small satellite bus that can be quickly adapted to carry multiple experimental payloads to various altitudes and inclinations. This STP mission, designed to evaluate radio frequencies in dense environments, was placed into orbit on a Pegasus small launch vehicle released from a B-52 aircraft over the Western Test Range off the coast of California. We also manage the Pegasus program as part of the Air Force Small Launch Vehicle program. We are also responsible for the extra-long Pegasus XL, which is launched from a modified L-1011 aircraft. The Pegasus XL launched the Rex-2 satellite into a near-perfect orbit. Our Small Launch Vehicle program also manages the new Taurus booster. This STP mission, with 2 experiments, including 1 experiment to study autonomous navigation, was launched successfully on the Taurus. Taurus increases our capabilities to quickly launch relatively small spacecraft into orbit. Our medium-class spacecraft missions carry one-of-a-kind satellites. For example, an Atlas Centaur booster was used to lift this joint DoD-NASA payload, designed to study the effects of radiation on microelectronic components. Several experiments can be combined onto one payload, such as the Argos satellite, which carries 8 experiments, including demonstration of this lightweight electric arc jet propulsion system. Argos is scheduled to be launched on a Delta II booster. We can also find extremely cost-effective rides for experiments by piggybacking them on host satellites from domestic and foreign agencies. For example, a Defense Meteorological Satellite Program spacecraft carried an ionospheric current systems and aurora experiment that measured variations of the magnetic field associated with auroras. Our operational location at NASA's Johnson Space Center at Houston, Texas, integrates equipment and trains astronauts to conduct experiments on the Space Shuttle. We have flown 160 payloads on 50 shuttle missions. On this mission, we flew 7 mid-deck experiments, including this Hercules experiment that uses a multispectral camera to automatically determine the location coordinates of features on Earth. On another shuttle mission, we sponsored an astronomy satellite that was deployed from the remote arm and was retrieved by the astronauts after its 40 hours of scientific observations. One of the other experiments on this mission was mounted on a hitchhiker bridge in the shuttle bay. It investigated the potential effects of glow and contamination on spacecraft and space-based sensors. Another mission carried 18 different experiments, including several testing various STP-sponsored space technologies, experiments addressing upper atmospheric and space modeling, and an experiment that is deployed away from the shuttle to observe engine plumes, gas releases from the shuttle, and other chemicals released from quick getaway canisters spun off earlier in the flight. Those observations helped to develop sensors and weapons for a ballistic missile defense system. Modified Minuteman II ballistic missiles will also be used as launch vehicles. The multi-service launch system will offer a modular test section capable of carrying a variety of payloads. To support suborbital missions, we've provided booster management and launch support for over 535 ballistic missiles and sounding rockets in support of R&D flight tests. Using refurbished Minuteman missiles, we can support multiple payloads for advanced missile systems tests. These missiles are also used as strategic test targets. Our team is responsible for coordinating the launches of missiles to be used as test targets by the MSX satellite, which will conduct a series of sensor experiments aimed at identifying and tracking ballistic missiles against various backgrounds. We also have sounding rockets that can serve as low-cost buses for suborbital flights of short-range recoverable sensors. We supported experiments that obtained valuable data to help design surveillance and tracking systems expected to operate in a nuclear-disturbed atmosphere. Our sounding rockets are also used as targets for theater missile defense testing, currently one of the major development areas in DoD. These tests provide invaluable data for use in interceptor development. Tethered aerostats and high-altitude balloons, managed by our office at Holloman Air Force Base, New Mexico, support near-space experiments, such as the SCRIBE experiment, which collects a database on various atmospheric conditions and clutter that could affect the performance of early warning systems. These platforms can remain constant at the desired altitude for long-term data collection. In most cases, payloads are recovered in good condition for refurbishment and reuse. From launch to orbit to data collection, processing, and dissemination, the Space and Missile Test and Evaluation Directorate provides our customers with continuous support. Our test support complex in communication with the network of ground support facilities assembled for test execution provides our customers with tracking, telemetry, command, and control. During test execution, our team monitors safety criteria, resolves anomalies, and refines mission procedures in real time. This command and control function will move from Onizuka Air Station, California, to the new Research and Development Support Complex as this part of the Directorate transitions to Kirtland Air Force Base. On-orbit tests are supported through the worldwide Air Force Satellite Control Network. We can also send deployable ground stations to any location worldwide. These self-contained systems are capable of providing compatibility testing in plant and in the field, as well as early orbit test support. Our state-of-the-art tools and equipment provide our customers with comprehensive data services to support processing, reduction, analysis, evaluation, and dissemination. Starting within hours of the test, evaluation reports continue through the various phases of the program. We're leading the way not only today, but in the future. Our Center for Research Support, located at Falcon Air Force Base's National Test Facility, is a modern satellite operations center dedicated to research and wargaming efforts. The Ground Systems Demonstration Laboratory, built jointly with SMC's Satellite and Launch Control Systems Program Office, allows satellite operators to test and critique prototypes of advanced command and control software for future operations. The Space and Missile Test and Evaluation Directorate, America's Space Test Center, the best in the world and getting even better.